Hello friend, welcome back. In last three lecture, we have discussed the conformational isomerism. In that isomerism, we have discussed various form of conformational isomerism. Now, in today's lecture, we are going to discuss the configurational isomerism. We are discussing that when there is no rotation of carbon-carbon single bond, this rotation is restricted. Then, if we found that two compounds having same molecular formula but having the different structural formula, then it is called as the configurational isomers, and the phenomenon is known as the configurational isomerism. The one best example of configurational isomerism is the optical activity. So, what is optical activity? Up to the UG level, you have studied the optical activity. Optical activity is the property of compound which rotates the plane of plane polarized light towards the right hand side or left hand side. It's called as the optical activity. For example, see here, if this is the plane of plane polarized light, this is plane polarized light, where this plane polarized light is passed from the solution of organic compound or any type of compound. So, when this organic compound absorbs this plane polarized light and emits the plane polarized light, then there is rotation of plane polarized light. See here, the plane is in this way, but now the plane will be shifted, the plane will be rotated either towards the clock hand side, clockwise direction, that is right hand side, or either towards the left hand side, that is towards the anti-clockwise direction. See here, this is the anti-clockwise direction. So, again, I tell you, this is the plane polarized light, and when this plane polarized light passes from the sample, a solution of sample, and this solution of sample absorbs the plane polarized light and again emits this light, but in this direction we are observe that the plane of plane polarized light is rotated toward the clockwise direction, that is on the right hand side direction, or anti-clockwise direction. That is left hand side. If any compound shows this property, then it is called as an optical active compound. If any compound do not show this property, then it is called as an optical inactive compound. See here, if any compound shows the optical activity in clockwise direction, rotation of plane polarized light in clockwise direction or right hand side, then it is noted as the plus sign or small d. D for the dextrorotatory. Dextrorotatory in Latin means the right hand side. When any compound shows the rotation in anti-clockwise direction or left hand side, then it is denoted as a minus or small l. L means the levorotatory in Latin. Levorotatory means the left hand side. Which are the criteria for a compound? By that compound shows the optical activity. The compound should be chiral compound. It means it should have at least one carbon atom, which will be the chiral carbon atom. And you know that what is the chiral carbon atom? Chiral carbon atom is the carbon atom which having four different groups. If any compound having a chiral carbon atom, then it shows the optical activity, and either it will be the clockwise or anti-clockwise. So this is very simple condition we have to keep in mind. If any compound will be optical active, then it must have to be a chiral carbon atom, and if any compound do not show the optical activity, it means it is optical inactive. Then there is absence of chiral carbon atom in this compound. So let us see here. Friend, this observation is found to be in a polarimeter instrument, but this is practical observation. What is about the theoretical observation? It means that in classroom, if we have the structure of any compound, then how to identify either this compound is optical active or optically inactive, and if this compound is optical active, then it is dextrorotatory or levorotatory. For the identification of such a type of observation, it means either any compound is dextrorotatory or levorotatory. By theoretically, there is one method given by Chan, Ingold and Prelog scientists. These are the three scientists which use this method, and this is known as the Chan, Ingold and Prelog system for the identification of R and S configuration. So firstly, I write here R and S configuration. R means the rectus, that is right hand side, and S means the sinister, that is the left hand side, that is anti-clockwise in Latin. So therefore, if the compound shows the R configuration, then it will be the dextrorotatory, and if the compound will show the S configuration, then it will be the levorotatory. So for identification of R and S configuration, for determination of R and S configuration, we have to discuss here Chan, Ingold and Prelog system first. In Chan-Ingold Prelog system, there are given some rules for the priority that we are discussing here. Rules for priority. The first rule is more the atomic number, more is the priority. More atomic number, more is priority. If you consider here, if any carbon atom having attached hydrogen and the hydroxyl group, now see here, this carbon atom here is attached hydrogen and here is attached the oxygen. So hydrogen having atomic number 1 and oxygen having atomic number 8. So therefore, this is the this oxygen having more atomic number. Therefore, this having first priority over the hydrogen, and hydrogen having the second priority. Now, the second rule is if first atoms are common, they go to the second. See here, this is the carbon atom which attached to the another two carbon atom. It means these two first atoms are the same. Then there is a consideration of the next atom, that is the second carbon atom, second element. So this is iodine here and this is chlorine here. We know that iodine having atomic number 53 and chlorine having atomic number 17. Therefore, iodine have first priority here. and chlorine have second priority. If the second atom will be sent, then go to the next atom. The third rule for the priority is, if the atomic number are same, then consider the mass number. Atomic number same. If atomic number are same, then consider mass number. See here, if any carbon atom attach the hydrogen, deuterium and tritium, we know that these are the isotopes. Hydrogen having atomic number 1, deuterium having atomic number 1, tritium having atomic number 1. All these three atoms having atomic number 1, then we have to consider the mass number. Hydrogen having mass number 1, deuterium 2 and tritium 3. Therefore, the elements which having more atomic mass number, it will having the first priority. So it having the first priority, deuterium having the second and tritium having the third priority. Now the fourth rule is multiplication rule. Multiplication rule is related to the multiple bond. If this carbon atom having attached to carbon-carbon double bond and this carbon atom having attached to the carbon-carbon triple bond, then consider this carbon attached to this carbon atom and again this carbon atom attached to the two carbon atom and this carbon atom attached to the another three carbon atom. Therefore, this having the first priority and this having the second priority. The fifth rule is the cis conformation is more prior to the trans conformation. See here, if this is the trans and if this is the cis, see, if this is the cis and this is the trans here, so cis conformation having more prior to the trans conformation. So therefore cis conformation having first priority, then the trans priority. The sixth number is R having R configuration having more priority. To the S configuration, if there is a case in which two groups are the same but one having the R configuration and another having the S configuration, then we have to give first priority to the R configuration than the S configuration. And the last priority is and the last rule is lone pair of electron having least priority. Lone pair of the electron having least priority. If there is any case in which lone pair is present, then give the least priority to the lone pair. So all these are the rule of priority in Chan Ingold Prelog system for the determination of R and S configuration. Firstly, in determination of R and S configuration, we have given the priority to the four different group, and then after we have to observe the least priority group. Least priority group is it should be the apart from the observer, and then we are going to decreasing order of priority. So that is from 1 to 2 and 2 to 3. And then if the sequence will be clockwise, then it will be the R configuration, and if the sequence will be anti-clockwise, then it will be the S configuration. Here, some examples of R and S configuration are discussing. And see here, this is the first example in which here is the OH. So in this example, you can see here, this is chiral carbon atom which having 4 different groups. This is hydrogen, this is ethyl group, this is ethyl group, and this is the hydroxyl group. If we observe all these 4 groups, then give the priority to the hydroxyl group first, because here is the oxygen. Then here are the 2 carbon atoms. Then go to the further carbon atom. So this is CH3, this is CH2 here. So therefore this is second, this is third, and this is the 4th priority. Now the least priority group is toward the is denoted by the dotted line. Therefore it is apart from the observer. So hence we go from first to second and second to third. And see here, this is the anti-clockwise, and hence this configuration is the S configuration. This is the example of S configuration. Now the another. This is second example in which we can see here, to this chiral carbon atom there is attachment of chlorine, oxygen, hydrogen, and CH3, out of which chlorine having more atomic number, that is 17. Then after oxygen, so therefore chlorine having first priority, oxygen having second priority here, and this carbon having third priority here, and hydrogen having fourth priority. And the least priority group is towards the back side, because it is denoted by the dotted line. So therefore we have to observe now these 3 groups. So we are going to from first to second and second to third. Therefore this is the clockwise direction rotation, and hence this compound shows the R configuration. Now in the next example, see, this is the nitrogen which having the 4 different groups, that is the hydroxyl group here, ethyl group here, methyl group, and this is the lone pair of electron. And in the priority rule we have discussed that the lone pair of electron having the least priority, therefore it having the 4th priority, this oxygen having first priority, this ethyl group having second priority, and methyl group having the 3rd priority. So therefore we move from 1 to 2 and 2 to 3. So it will be the anti-clockwise direction, and hence this is the S configuration. Now in case of the next example, see here, this is the chiral carbon atom which attach 4 different groups. This is the phenyl group, this is the C triple bond CH group, and this is the hydroxyl group, this is the hydrogen. If we see here, these are the 2 hydrogen, this is the oxygen. So oxygen having more atomic number than the carbon atom. So therefore this hydroxyl group having first priority. Now see here, this carbon attached to the these 2 carbon atom, and this carbon attached to the single carbon atom by the triple bond. But here this is, if we multiply the group, then we can write here this attached to the 3CH group, and this attached to the again 3CH group. But this 3CH group having next atom carbon, this CH group having next atom hydrogen. So therefore this is second priority, this is third priority, and fourth priority goes to the hydrogen, and hydrogen is this is clockwise, and hence this is the R configuration here. Now in this case, see here, this is chiral carbon atom. This chiral carbon atom attached to the all these oxygen, all these groups. So this is carbon here, this is carbon, carbon, carbon. But in benzene ring, in phenyl ring, the carbon atom attached to the next carbon atom, but here are the carbon attached to the oxygen atom. Here are the 3 oxygen atom. Here are the again 3 oxygen atom. But see here are the oxygen to the 1, 2 and 3. Here are the carbon attached to the 1, 2 and 3. But here is the CH3, therefore it is having first priority, it having second priority, it having third priority, and it having fourth priority. See here, this least priority group is not towards the behind side because it is not denoted by the dotted line, and hence we have to change this configuration. It means there is a one rule in Chiral Prelog system. When the least priority group is not towards the backside of the plane, then change the configuration. If your configuration will be R, then changes to the S, and if your configuration is S, then changes it to the R configuration. So we are going to 1 to 2 and 2 to 3. Therefore, this is the S, but S changes to the R configuration. Now, in this case, see here, if this is the chiral carbon atom and attached to the all benzene ring, but this benzene ring having iodine here, hence it having the first priority. This benzene ring having chlorine to the ortho, it having second priority. It attaches to the chlorine meta, it having third priority, and this having the fourth priority. So we move from 1 to 2 via the 4. So if this is the 2, we are going to 1 to 2 via the 4 and 3. See, 1 to 2 and 2 to 3. So it will be the R configuration. But see here, least priority group is not denoted to the back side. Therefore, R changes to the S configuration. Now, in this case, see, this is the chiral carbon atom. This pH having first priority, then ethyl group having second priority, methyl group having third priority, and the hydrogen having fourth priority. Least priority group is toward the back side of the plane. Therefore, the configuration will be as it is. So we move from 1 to 2 and 2 to 3. So see, in this case, we move from 1 to 2, not in this direction because 4 is here. We move from 1 to 2 via the least priority group. So this is the anti-clockwise direction, and hence this is S configuration. Now, in this case, there are 2 chiral carbon atoms. One is here and another is here. Here to this chiral carbon atom, there is a one hydrogen attached to the back side because the chlorine is toward the above side. So we can give the priority. This is first priority. See here, this is CH2, then this is CH2. If both groups are same, then go to the next. Here is the CH2, here is the CH. But this CH attached to the OH, and hence it having the second priority, it having the third priority, and hydrogen having the fourth priority. So therefore, move from 1 to 2 and 2 to 3. So this is the R configuration. So we can write here this is the R configuration. Now, in case of this chiral compound, see this hydroxyl group having first priority. These are the 2 CH2. See here. Here is the hydrogen here to the above the plane because hydroxyl group is the below the plane. Therefore, hydrogen will be the above the plane. So these are the 2 CH2, but these 2 CH2 attached to the Cl here. So therefore, this having second priority, this having third priority, and hydrogen having fourth priority. So we move from 1 to 2 and 2 to 3 by the anti-clockwise direction. But in this case, the least priority group is above the plane or in front of the plane, but it should have toward the below the plane. Therefore, the configuration will be changes S to R configuration. So this carbon having R configuration. Now, in this case, here is a hydrogen towards the back side. Here is a hydrogen towards the back side. This OCH having first priority. See, in these 2 carbon, this is the CH2 attached to the next therefore it having second priority, it having third priority, and hydrogen having fourth priority. So we move from 1 to 2 and 2 to 3. This is the clockwise direction. So this chiral component or this chiral center shows the R configuration, and now in this case this iodine having first priority, this group having second priority, this having the third priority, and hydrogen having fourth priority. We move from 1 to 2 and 2 to 3. So this is the S configuration. So in such a way, how to determine the R and S configuration is here. So firstly we have to remember all the rules of Chiral Prelog system, and then give the priority to the 4 different groups, and then after observe in such a way that the least priority group will be towards the back side, and then we have to give the sequence first priority to second, second to third, and if the rotation will be clockwise, then give it the R configuration name, and if the rotation will be anti-clockwise, then it will be the S configuration. Remember one thing: if your last priority, fourth priority is not towards the back side, then the configuration will be changed. It will be changed from R to S or S to R. Friends, the remaining part of this chapter will be discussed in next lecture. Thank you.